Welcome to the Seaward 5th edition Code of Practice in-service inspection and testing webinar. Thank you for joining us today on the introduction to the 5th edition Code of Practice. In this presentation, we will talk you through all the changes that have been made from the old 4th edition to the now new 5th edition. During the presentation, please do use the question section on the screen to ask any questions, so you can type those in. We'll do our very best to answer them all as we go through, and we'll also have a live Q&A session at the end. So for those of you who don't know who Seaward are, we see ourselves very much as market leaders in electrical safety testing equipment. We were established nearly 40 years ago now, in 1982, so 38 years ago. And we're a British company based up in the northeast of England, and the majority of the materials we use are actually sourced locally in the northeast as well. So we see ourselves very much as a British manufacturing company. Our product range includes PAT testers, Seaward probably best known for our PAT testers, but we also have our medical testing products, high voltage testers, solar PV and renewables products, and also our manufacturing and production line testers. So there's quite a lot going on at Seaward other than just PAT testing, and obviously if you want to check out our website seaward.com, you can look for more information about that. So just by way of a bit of an introduction to the 5th edition, work actually began on the 5th edition Code of Practice at the start of 2019, so a long time ago now. And was published, the Code of Practice was actually published in September 2020. So it's been a long time in the making, really, from that side of things, over 18 months, really, in the sort of creation of the Code of Practice. It replaces the 4th edition that was introduced back in 2012. So when we had the 4th edition, that's, 8 years ago now, really. So it's been quite a while since we've had an update to the Code of Practice. So there's a committee made up of a number of representatives from various industry sectors that contribute along with the IET in updating and creating the new code. And Seaward actually sit on the committee representing our trade body, Gambika. Although the 5th edition reinforces the principles of the 4th edition, it is significantly different in structure and adopts a more streamlined approach. This is to reflect the need for equipment maintenance, risk assessment, and in-service inspection and testing. So yeah, the Code of Practice has been very much sort of restructured. It's been put in a more logical order. It's meant to read a little bit better and really take you through the bits that you need to know in a better order. The old Code of Practice tended to jump around quite a lot, so there's been quite a lot of work done to actually streamline the Code of Practice in that way. Part 1. Changes to equipment categories, classifications and electrical tests. So the Code of Practice reinforces the need to include all electrical equipment that does not fall under other recognised established standards or processes. Section 4 gives examples of equipment that is covered within the scope and equipment that is not. Again, that's something that's been, as we use the term there, reinforced within here in section 4 is a clear scope type statement. So it gives examples of what is within the scope of the Code of Practice, within the scope of PAT testing, and what isn't. Previous equipment classifications such as portable, fixed and stationary have been removed to allow clear guidance for duty holders regardless of how portable the equipment might be. So again, important changes there to terminology. These old terms like portable, movable, fixed, stationary, all these sort of things, were always just terms that were used within the Code of Practice. They were never in the legislation or anything like that. They were just terms that were used. The only problem was that people gave legal meaning to them. So, they said, oh, well, something that's portable is covered within the regulations. If it's not portable, then it's not covered, so it doesn't need testing and all these sort of things. So there's a lot of confusion based on these, and you'll remember the old definitions, like, is it 18 kilograms or less and in weight and all these sort of things. All that lot's now gone. We just talk about equipment testing. We test electrical equipment, and it's all streamlined a lot more from that side of things. So all references to portable appliance testing, portable appliances and PAT have been removed to further emphasise the need for maintenance, whether equipment is portable or not. So yeah, although we still probably at Seaward and everybody else will probably still use the term part and portable appliance testing, technically all those references have gone from the code of practice. The word appliance, interestingly enough, in the international electrotechnical vocabulary, refers to domestic electrical equipment, domestic appliances. So again, the word appliance, the reason that's been removed is because it's only meant to be used in a domestic context, and generally that's the one place you probably don't do pat testing. So from that side of things, we talk about equipment that needs testing and that side of things. There will be some crossover, I'm sure, and there will be some terminology where everybody will still carry on using the term pat, I'm sure. But in the code of practice, they've tidied up the language and they've tried to make that a lot clearer for duty holders. So under classifications of equipment, there's been an introduction of new equipment categories, ES1, ES2, ES3, to really replace SELV, ELV, LV, in that order, really, from that side of things. They don't directly replace these. These are just new terms that are included in the standards, and they need to be defined in here. So you still may have equipment that is SELV or is still specified as SELV, but you'll see these new terms ES1, ES2, ES3 being used mainly in the international and European product safety standards. So awareness of the new equipment categories is important, although they do not really change any practical application. They will be used and become more common in the future. So yeah, again in here, and we'll probably do another webinar further down the line to actually go into these things in a bit more detail. And there is actually quite a lot in the appendices of the new code of practice that covers ES1, ES2, ES3. So ES1 generally is equipment less than or equal to 30 volts AC or less than or equal to 60 volts DC. So this is your sort of really safe stuff. This is the stuff you might be using in bathrooms and things like that and sort of sensitive locations. ES2, anything less than 50 volts AC, 120 volts DC. So that really would have matched in pretty much with your old ELV systems for that side of things. So it would have, your cells and PELs and things would have probably fitted into that voltage bracket. So again, that's more sensitive equipment, maybe equipment use outdoors, things like that, may fall into that ES2 category. And then ES3 really is things that are above that. So generally ES3 would probably be your normal low voltage equipment that we would talk about, your normal mains powered equipment. So again, I'm not going to go into too much detail on these now because in reality, it won't affect what you're doing day to day that much. These are just new classifications that you need to be aware of. And I say we'll probably do a more detailed webinar later on to cover these. Now, another change in terminology or another introduction to the code of practice that we need to be aware of is Class 2 FE, Class 2 Functional Earth, that stands for. So Class 2 FE equipment, formerly known as ITE equipment, is a new introduction to the 5th edition. And the symbol was introduced in the new BSEN 62368 product safety standard. So you can see there in the bottom right hand corner there's actually a new symbol that was introduced in that EN standard to cover Class 2 FE equipment. So protection against electric shock still relies upon supplementary or reinforced insulation, but requires a protective conductor for functional reasons. The most common examples of these are switch mode power supplies used in a variety of applications, especially IT equipment such as laptop computer chargers. Class 2 FE product is tested in the same way as a normal Class 2 equipment, with the addition of an earth continuity test to confirm connection to the functional earth. So from that side of things, from an electrical safety point of view, this is Class 2 equipment. The electric shock protection is provided by double or reinforced insulation, just like it would be with all other Class 2 equipment. So when you're checking the safety of it, we still treat it as normal Class 2 equipment. However, for functional reasons, there is an earth connection. That's not there as part of the protective measure like it would be with Class 1. It's not protective earthing. It's functional earthing. It's there to make the equipment work. It's there to for screening, for bonding, those sort of things. So in many cases, people will want to actually test the continuity of it So you may want to do a continuity test to actually make sure it's there, it's continuous, because it's meant to be there as part of the correct functioning of the equipment. And if it isn't there, the equipment might not function correctly. So the duty holder may do a risk assessment and decide, actually, in addition to the normal Class 2 tests, we want to actually do a continuity check, a functional check on the functional earthing. Obviously, that can be carried out with a continuity tester. And I'll talk later on about some of the change we've made to the Seaward products, but we have actually on a majority of the products, we've actually added in a test sequence in there for Class 2 FE, so you have got a way of testing Class 2 FE. One bit I just want to mention in here because it's important. The actual pass-fail limit. All we're checking is for continuity. Is it continuous? Is it relatively low resistance? There is no specific pass-fail value for this, although the equipment manufacturer may be able to provide you with typical values or values that they would expect to see on their particular equipment. So the 0.1 plus R, the normal earth continuity limit, doesn't apply for this because it's not designed for protective earthing. So it may have a higher earth reading or resistance reading than you would normally expect on normal equipment. So really we are just confirming, is it continuous, is it connected, as opposed to is it below a set resistance value, because each piece of equipment could be different, and it's not there for protective earthing, it's there for functional earthing. So just be aware of that. So the pass-fail limits aren't specified 100%. Like I say, individual manufacturers may do that, but what we're really doing is we're just checking, is it there? Is it continuous? So it's really a functional check as opposed to an official test or measurement. Now there's a new note been added on a 0.5 earth continuity pass-fail limit. So just something we need to mention, really. This has been added in as a note. In some of the drafts, you may have seen this in the actual table. In the final published version, it's been taken out of the table and it's been put in as a note. There was a lot of discussion because basically in the draft they wanted to add in this 0.5 limit, and where it covers some, and I say it's some, it's a very, very small amount of old equipment may actually give a higher earth continuity reading, and that's because it was designed to an older standard. And that was what it was designed to do. So the actual standard it was created to originally, and we're talking equipment from a long time ago, may not meet the 0.1 plus R. Not because it's deteriorated, but that's because of how it was designed in the first place, the cable sizes, the lengths of cables, things like that. So going back through the old product standards, there is a small section of equipment that may have higher readings up to as much as 0.5. Now, the aim was to put this in the table and just say older equipment, 0.5, but then what is old equipment? How is it defined? So it was quite confusing. So we argued quite strongly in the committee and got it reduced down to just a note. So there is a note in there that says older equipment, you can, or the duty holder can determine and say, actually, we're happy with this 0.5 ohm reading. It's not really a change to the code of practice. It's just the fact that the code of practice now recognising that there was some old equipment to, very old standards that may actually be higher than the 0.1 plus R, so they've included this in. But realistically, from my point of view, don't think too heavily about it. Still use your 0.1 plus R. And as I've put there on the slides, the pass-fail limit for earth continuity remains the same as the 4th edition. It's still the 0.1 plus R. There's nothing that's changed in there. The only addition is under the table in the notes, they've put this little mention in there about the 0.5 ohm. What we have actually done on the Apollos, we've put new test sequences that we're preparing for the 5th edition Apollo firmware update, and in there we have put a 0.5 ohm test sequence in there just to cover this. And obviously, if you're doing your own test sequences, you can include those, and you can write your own sequences to allow for that. But we're just making you aware that it is in there, but it's not a major change. This is just recognising there was some older equipment that wouldn't comply with 0.1 plus R, because of the standards it was designed to, but we are talking a tiny amount of very old equipment that would fall into that category. And obviously using the 0.1 plus R is always on the safer side anyway, really. So I would imagine most duty holders will still just go with the 0.1 plus R and not the 0.5 ohm option. So changes to the leakage tests. Protective conductor or touch current tests can be used as an additional test to the insulation test. Now, it's important to note that leakage testing is no longer instead of insulation test, but as well as an insulation test. So I'll talk in a moment about there's a new flow chart that's been added in. And this was an important thing because in the past, it's always been you could do an insulation resistance test or you could do a leakage test. It was perfectly acceptable to do one or the other. It wasn't, you know, one and the other. So the way it's specified now in the 5th edition is that you must do an insulation test. And then if you've done an insulation test, you can then do a leakage test as an additional test. What we can't do is do a leakage test on its own. We must do an insulation resistance test before we carry out a leakage test. So just be aware of that difference. What they're saying is that before it was either or, you could do a leakage test or you could do an insulation test. Now it's you must do an insulation test and you can also add a leakage test on as well should you need to. So just be aware of that. It's a slight difference, and I'll talk about the flowchart in a moment. So these tests originate, so the leakage tests originate from manufacturer production compliance tests. So generally the origins of the tests, certainly the ones that were applied under the 4th edition, were really something that was done by manufacturers in laboratory or production environments using quite complex test equipment and often, you know, sort of wrapping things in tin foil and all sorts of methods that needed to be done to actually achieve these values. And these values were just then taken and put into the code of practice. So in the previous editions, we had pass-fail limits of 0.25 milliamps for Class 2, 0.75 for Class 1 portable or movable equipment, and for stationary equipment, portable handheld was 0.75, movable stationary was 3.5 pass-fail limits. And that depended, as I say, on whether it's Class 1, Class 2, and what the type of equipment was, whether it's portable or stationary. So one, that's quite confusing. So people used to get very confused with that, and they'd fail equipment that should pass and things like that. But also, it's quite hard to achieve, you know, the actual level of accuracy that you would get in factories and things like that. So in the new code of practice, they've changed that. They've gone for a more real-world limit. And actually, this is to align with some of the more modern product standards tend to be standardizing around this value of 5 milliamps. So the new leakage limit for the 5th edition code of practice is now 5 milliamps, and this applies to both Class 1 and Class 2. So from that side of things, it's just a 5 milliamp limit, whether that's a PE current test, a touch current test, whether it's portable, handheld, movable, stationary, whatever the type of equipment is. We now just do a leakage test, and the limit of that is 5 milliamps. So we've got a 5 milliamp leakage limit applied to everything. So that's actually quite a big change, really, when you look at going from 0.25 all the way up to 5 milliamps. So what we've done with our products is we have actually made changes to the products, to the new 5th edition range of Seaward testers, that will allow them to test all the way up to 5 milliamps for both PE current and touch current. So that's a change. So when we talk about testers being 5th edition compliant, that's really what we're talking about. We're talking about we've made that change, so they will actually measure all the way now up to 5 milliamps for both PE current and touch current. There's also something you might have noticed, or you might not have noticed in the code of practice, is the removal of the alternative leakage. So again, people were getting quite confused with what does the substitute or alternative leakage test do? Why is it different to this? Why are we getting slightly different readings and all those sort of things? So in an aim to really sort of tidy up the code of practice really and just make it a bit more simple for most people to understand, there isn't now specific separate reference in there to the alternative leakage test. So although it's not specifically mentioned in the code of practice now, the substitute alternative leakage test is still an optional test where you haven't got access to mains voltage, where you want to test on battery and you want to do a leakage test. It's still quite a powerful test, still quite a useful test because it tests with AC. So it's an AC test as opposed to the insulation resistance test, which is a DC test. So there are faults that you will detect, and there is leakage that you will detect by using AC that you wouldn't use with DC from that side of things. So we still feel it's a valuable test, and obviously we'll still include that on our products, but it's now not specifically separately mentioned within the code of practice. Obviously, if you are using a substitute alternative leakage test, you can still use the 5 milliamp figure. You would still use the same pass-fail limit for that. But obviously, it's just another method of doing it, and the committee felt that it was just getting a bit confused. I think with the leakage tests, and people were getting a bit confused about what it was saying and why it was different to other tests and things. So it was just decided that would be removed. So just be aware of that if you're wondering where it's gone. It was just removed really for that reason. So the 5 times RCD test. So more emphasis has now been put on the 5 times RCD test, as this tests for additional protection against electric shock. So this is very much something that's come out of the 18th edition. You know, they've really been hammering the importance of doing 5 times testing on RCDs, because if the RCD is there to provide additional protection against electric shock, that means it's going to be high currents. It means it's got to work at this 5 times rating. So they've really switched round now with the fixed wiring testing with the 18th edition onto 5 times testing is the most important test. You must do 5 times testing. However, if you're checking that the device has actually been manufactured correctly and is to the current standards, then it's good practice to actually do a 1 times test as well. So we generally recommend, and on our products, we'd have a 1 times test and a 5 times test, and obviously they'd be repeated at 0 and 180 degrees as well. And the reason for that is generally you will see a lot of substandard or counterfeit RCDs, or very cheap plug-in RCDs that may well pass a 5 times test. Because you're putting a lot of current through it, you're putting 150 milliamps through, yep, passes the 5 times test. But then you actually do a 1 times test, you find it fails. And that's quite common with substandard devices, where they will work at the higher current but not the lower current. So we still think that it's actually important that you do test at the 1 times and the 5 times. But in the new code of practice, they've actually put in there that the essential test is the 5 times test. So again, when we're talking about 5th edition compliant testers, make sure that your tester will do a 5 times RCD test when you're doing RCDs, because that's now a requirement of the 5th edition code of practice. Now, I mentioned the new flowchart. This is a Seawardized version of it. And apologies if there is any typos on it. It's brand new, straight hot off the presses, and we'll be producing this as an infographic, and we'll have this available online and all sorts of things. So you're just getting really a preview of what's on here, and I know it's going to be quite small, so you're going to struggle to read it. But if you have a look in your code of practice now, one of the great things that's been included by the IET is actually a PAT testing flowchart. So a flowchart where you start at one end, you follow your way through the process, and actually come out the other end, and it explains to you exactly how you do each test and how it works all the way through. So again, great to have that, great piece of equipment, really to add into the book, and to have, we're hoping to do these as posters and things like that as well. So again, if you're training or anything like that, it's great to have a flow chart where you can just work your way through all the way through the process and actually pick up what's going on with these things. So really interesting to do that, and I think that's a great addition to the code of practice. That, and as I say, this is just a quick representation of it. So if there is any typos or anything on here, just be aware of that. We've just put this in now, but there will be a new version of this coming out shortly. In part 2, we'll look at defining the frequency of inspection and testing. The most significant change in this edition is the removal of Table 7.1, Guidance on Initial Frequency of Inspection and Test, which has been replaced with guidance on risk-based assessments. The likelihood of damage to equipment will depend on its frequency of use, the environment in which it's used, and the skill of the user. The frequency of inspection and testing will vary for different equipment, different workplaces, different users. There may be requirements specified by insurance companies, landlords, or the interested parties. So all of this needs to be taken into account when we're setting frequencies, when we're actually carrying out the risk assessment So these are all important points, and we'll go into a bit more detail in the coming slides. So the final decision should always be made by the duty holder on how frequently inspection and testing should be carried out. The duty holder should take into account consideration of the risk of damage that might lead to injury or loss, and where possible this should be supported by records. Now, important point, we've put it in bold to emphasise it, there's no right or wrong answer to inspection and test intervals, inspection and test frequencies. The right answer is the answer that's been arrived at by doing a risk assessment and assessing the risk and using inspection and testing as a control measure to control the level of risk that the duty holder perceives. So risk assessment examples have now been included in the appendices. So if you have a look in the appendices at the back of the Code of Practice, you'll actually see a couple of different scenarios there where they've carried out risk assessments, and that just gives you a rough idea of the things you need to look at and maybe how you carry out your own risk assessments. It's important that in light of the removal of Table 7.1 that duty holders actually revisit their inspection and test frequencies and ensure that they are risk-based, and that policies don't just refer to now obsolete tables. So from that point, you know, your risk assessment policy or your customer's risk assessment policy or your customer's pat testing policy might just say, well, we test according to Table 7.1 in the IT Code of Practice. There now is no Table 7.1. So from that side of things, they may need to look again and make sure that they have actually risk assessed the frequencies rather than just picking them from a table which has now disappeared. So we talk about this a million times, and you've probably seen this slide a billion times, but this is an extract from the Management Health and Safety at Work Regulations 1999, and this is the one that actually says that we have a legal duty to do risk assessment. So every employer shall make suitable assessment of the risks to the health and safety of his employees to which they're exposed whilst at work, and the risks to the health and safety of persons not in his employment arising out of or in connection with the conduct by him of his undertaking. Quite a lot of words in there, but it's just reiterating the fact that we have a legal duty under the Management of Health and Safety at Work regulations to do risk assessment. So again, there's probably a stronger legal case for risk assessment than there is for actually doing the actual equipment testing in the first place. Now, how often should we test? What does the duty holder need to consider? Well, generally it's a balance, and this is hence the diagram here of what we tried to do. There's two things we have to balance out. We've got to do it enough to prevent danger. We need to be able to test enough to prevent danger. So we could test every day, and if we're testing every day, that'll be enough to prevent danger, hopefully. However, that wouldn't be reasonable and practical. In the legislation, it says reasonably practicable. What's reasonable and practical? So again, we're trying to work out that balance. What's enough to prevent danger, and what's also reasonable and practical? What can we do? And that's really where the risk assessment comes in. The risk assessment is looking at what's the level of risk and actually putting these control measures, setting your frequencies based on what's enough to prevent danger, but also what's reasonable and practical, what fits in with what we can do in the real world. So again, as a duty holder, that's important for them to make that association. And if you're talking to customers, again, useful analogy there to just say, look, with your risk assessment, that's what you're trying to do with the risk assessment. That's what you're trying to achieve. So the guidance on risk-based assessments, to accurately reflect the legal requirements of Electricity at Work Regulations, Regulation 4, Paragraph 2, a risk assessment should be carried out to evaluate the frequencies between inspection and testing. So in the Code of Practice, they've always had 7 things that we've considered, and under the 4th edition, we always had these 7 things that we went through. The environment it's being used in, who's going to use it, the actual construction of the equipment, is it class 1, class 2, the type of equipment, is it maybe handheld equipment, stationary equipment, the frequency of use, how often we're going to use it, the type of installation method, so is it in conduit, trunking, is it cable run across the floor, and also our previous records. Now what they've done for the 5th edition is they've actually added in another one there, and I just want to explain that really. It says the functional in-service life, e.g. leased equipment. Now, the functional in-service life is what they're saying is that if you've got a policy within your organisation that you lease your vending machine, say, and you know that vending machine has been leased, and actually the lease period is for 12 months. that is something that you can factor in. You know you're going to get a new machine every 12 months because that's the lease period, that's what's in the thing, that one is going to be taken away and a new one is going to be put in there. Similar with IT equipment, you might have a maintenance or a leasing arrangement with your IT provider, and you know that every laptop is going to last 2 years and then it's going to be taken away, got rid of, and a new one's going to come in. So again, those sorts of things can be factored in when you are actually doing your risk assessment. But generally, the list is pretty much the same as the things. And I always point out, although these are the ones that are in the Code of Practice, this is not an exhaustive list. There are lots of factors like the age of the equipment and things like that that you may want to factor in that isn't on this list. This is just the key points that are listed in the 5th edition now. And obviously they've added that new one in there at the bottom, the functional in-service life too. So just again, this is a bit of sort of going back to basics, but we just wanted to talk a little bit about what actually needs testing. No real changes here under the 5th edition. This is just reiterating so you can understand the context for the other requirements that are in there. So what needs testing? So in Regulation 4, Paragraph 2, Electricity at Work Regulations, it says, it uses the term systems. And this refers to electrical systems and includes electrical equipment. And just remember now in the 5th edition, this is why we're using this term electrical equipment to just describe anything. And electrical equipment, as defined in the regulations, includes every type of electrical equipment from, for example, a high voltage transmission overhead line, so power lines, to a battery powered hand lamp. There are no voltage limits in the regulations. The criteria are whether danger may arise. So that's the key thing. If danger could arise from it, then we're concerned about it. Then we need to know what's going on with it. So remember, the Electricity at Work regulations applies to equipment used in places of work and to work equipment. So that's the important thing as well. This is equipment in place of work and equipment that we're using for work purposes. So this doesn't include stuff in your own domestic home and things like that as well, unless it's obviously there for work purposes. So just be aware, this term equipment, this is why we're going back to basics, to actually understand the terminology in there. And, the legislation has never used the word portable or, part or anything like that. So the duty holder must risk assess all electrical equipment used in the place of work or for work purposes. This should include battery-powered equipment, three-phase equipment, and equipment that is permanently connected to the electrical installation, such as hand dryers and cookers. The risk assessment will determine the type and frequency of inspection and testing that will be carried out on the equipment and any other safety measures that will be employed, for example, RCD protection. So when you do the risk assessment, you can put in all these extra factors. So if you've got RCD protection, that can be factored in. That equipment might not need testing as frequently as something that hasn't got RCD protection. So all of these extra things, if people are trained, if there's signs, if there's other factors that you need to include, that's all got to go into the risk assessment. You can consider all of that. So the use of scoring systems, this is something I talked about in our recent Pat Refresher webinar series. Some duty holders like to use a score-based system to simplify the process of risk assessment. And the way this works is we just use a scale. Could be from 0 to 10 is the example I've put in here, but it could be any number really, 0 to 100 or whatever you want, to assign values of the probability and impact. So 0 being none, 10 being very high. So the two values are then multiplied together to give a risk score from 0 to 100. Bands can then be created and frequencies mapped to the bands. So we could say anything that scores between 1 and 20, that would be low risk item, in which case that gets done every 5 years, for example. So just to use an example here, if we had a grinder on a construction site, 9-inch grinder on a construction site, the probability of maintenance is high due to the environment and the equipment type. So, you're in a rough, rugged environment, it's been picked up, put down, moved around. So we'd say it's probably quite a high score. So we'd give it 9 out of 10 for the probability. What's the likelihood of maintenance, of this thing needing maintenance? we've given it a 9 out of 10. What's the impact? So the impact is how people going to be affected if it does go wrong. So the impact is also high due to the environment and the equipment type. So if this grinder does go wrong, we could be in a muddy puddle on a building site. Also, it's a grinder. You know, there's bits flying around. There's the guards. There's the blade. All those sort of things need to be factored in. So realistically, somebody could be quite badly injured if that thing was to go wrong. So again, we've given that an 8 out of 10. So we've got a 9 out of 10 and an 8 out of 10. They get multiplied together, gives us 72 out of 100. And if our policy said that we put it into bands and we said, right, 72, if it's between 70 and 90, then it needs testing every 3 months with a combined inspection and test. So you can imagine how a duty holder could actually set up a system and then just go through, make these judgments, and actually document why they've done these things, how it all fits together, and actually come up with a score-based or risk-based system. It's one way of just making it a bit less subjective and adding a bit more structure into it, really, from that side of things. And obviously, we're not saying this is the bang-on 100% way you should do it. We're just suggesting it's an option that some people like to use by actually doing these sort of score-based systems. Actually work quite well really when you're doing that, and obviously map it onto your frequencies. And then obviously you can change your rules. You know, if you get more incidents with a particular type of equipment, you can change the scoring, or you can change your bands, and you can actually work those things around. So you know, it's quite a useful suggestion really, a scoring based system. Now, obviously at Seaward, we've got a number of risk assessment tools that now under the 5th edition really come into sort of effect a little bit more from that side of things. So built into the Packard software, we've got the ability to do risk assessments. Built into our Apollo type testers, we've actually got the ability to do frequency-based risk assessments in there. And also with our Pat mobile app, we've also got the ability to do risk assessments in there. So because we're, now the 5th edition is saying that you go to a risk-based process, these have all got these risk-based tools on there, and obviously you could use those if you wanted to actually do your risk assessments on an item-by-item basis and do it that way round. So again, something to check out there really if you are thinking of moving to a risk-based system away from just a table-based system. Then again, something to check out really, products there from Seaward to support that. Part 3, British Standard, Plugs and Fuses. It is a requirement under the Plugs and Sockets Safety Regulations 1994 to have domestic and similar appliances fitted with fused plugs, primarily to the BS 1363 standard. Although the fuse in the plug is not fitted to protect the appliance, in practice it often does. The appropriate fuse rating for a plug depends on whether it is rewirable or not, the CSA of the flex, and what the manufacturer may recommend for an appliance. Whilst the fuse is selected to protect the flex based on the CSA, if stated, the fuse recommended by the manufacturer should be fitted. Fitting a lower fuse rating may give problems later, as some equipment has considerable inrush currents. As such, the manufacturer of the equipment may require a higher rating fuse than the flex is apparently rated for, e.g. a 5 amp fuse instead of a 3 amp. In accordance with the legislation, UK plugs and adapters to the relevant parts of BS 1363 and their fuses to BS 1362 should be approved by a notified body, bear the approval mark of the notified body, with the 3 most common being the British Standards Kite mark, the Astor mark, or the Nemco N mark. So you can see examples of those below. And they should also bear the license or certificate number designated by the notified body as well. So in the old code of practice, the previous method of advising fuse size was based on the appliance rating, effectively. So whether it was less than 700 watts or greater than 700 watts. So you might remember under 700 watts it was a 3 amp fuse, over 700 watts it was a 13 amp fuse. This has now been removed from the code of practice, and the following table has been added as a replacement. So what they've actually done is they've looked more at what the actual standards say and what the manufacturing guidance says. So this is the information that the manufacturer would be using when they actually manufactured, or when they chose their fuse for the particular equipment. So from that side of things, using the table actually means that we're actually using more of what the manufacturer would have used in the first place. Obviously, the aim, as we said on the previous slide, is to use the manufacturer's preferred fuse rating. So if the manufacturer has specified a 5 amp fuse, then we'd want to use a 5 amp fuse. If they specified a 3, we'd use a 3, and so on. But actually, by using the table now that's been included in the new code of practice, it should give you a better idea of why the manufacturers have chosen what they've chosen from that side of things. So yeah, it was nice and easy before when we had the 700 watts. Is it less than? Is it greater than? And then we'd pick the ratings based off that. But obviously that didn't always align with what we were seeing in real life in the field. And hopefully now the tables that are in there actually give you the values that are likely to align with what the manufacturers selected when they've designed their equipment. But really what we would recommend is actually using the manufacturer's figures where they're known. And this is obviously why testing new equipment is important, because you can actually start a benchmark. You can see what fuse was in that equipment when it was new, and then obviously just make sure over time that that rating is always always used with that particular piece of equipment. So it is a bit of a change to the guidance, the way of doing it, because we had quite a sort of blunt instrument before with the 700 watts greater than or less than guidance, whereas now all they've done is actually included the table from the standards, and this is the standards that the manufacturers would be looking at when they're actually picking the fuse sizes. So hopefully it will align with that, but I'm sure there's probably going to be a few anomalies and a few bits of head scratching that go into that as we move forward. Part 4, equipment built into furniture. This is a new introduction to the 5th edition, covered in section 411, where electrical equipment is supplied from a plug and socket arrangement and installed within purpose-built items of furniture, such as desks, lecterns, or shop displays. No specific standard exists for the installation, use, or ongoing assessment of this equipment, but now guidance is offered in the 5th edition, which essentially follows the principles of BS 7671, that's the 18th edition Y regulations, and BS 6396, electrical systems in office furniture and educational furniture. These types of equipment should be included in your risk assessment policies, visual inspections, and maintenance programs. Electrical test and inspection should be carried out on all appropriate parts, such as power blocks, extension leads, RCDs, built-in equipment, and any bonding. Visual inspection, earth continuity testing, insulation, polarity, RCD, and depending on the equipment type, PE conductor or touch current leakage may all be required. Now, there's a lot more in the code of practice going into details on this, and I think this is something, again, I've mentioned this a few times before, that we'll probably be picking up in more detail in a later webinar. So for now, just be aware this type of equipment has been added in. It's something you probably want to have a good read through and just familiarise yourself with what's changed in there, and actually just understand the fact that it is in there now. But I think it's probably something we'll pick up at a later date in more detail as well. Part 5, counterfeit and substandard goods. Counterfeit equipment is a known issue and is on the increase. Such equipment can be hard to identify as the packaging, labelling and safety marks can look very similar. Using reputable suppliers helps reduce the chance of obtaining counterfeit equipment, but checks should still be made. Products that do not comply with the appropriate safety standards, the retailer, and if necessary trading standards, should be informed. Although apparently compliant equipment should not need electrical testing when new, the operative may decide to conduct occasional spot checks on products. Users should pay careful attention to the safety marks to ensure that they are exactly correct. 2 examples are shown below. So again, we've got the European CE mark, which we'll be very familiar with, and the not so reputable China export mark, which is effectively a clone of that mark, or a facsimile of that mark, a counterfeit version of that mark. And again, that doesn't really mean anything. It doesn't mean it complies with the CE marking requirements. It just means that somebody's printed a C and an E on there from that side of things. So just be careful of the way it's laid out. You can see the spacing between the characters is very different on those. Another one that you may well come across is the actual British Standard Kite mark, but the British Standard Kite mark's been reversed. The S has been reversed, and again, that's just a counterfeit version of the kite mark, and something again to look out for. Now, have you seen plugs like this? These are unfused plugs. So again, we've got unfused plugs, the size of them, the size of the pins, the clearance distances to the edge of the plugs, and even on the first 2 there, you can see that they've actually got a half-sleeved earth pin. So again, the half-sleeved earth pin causes us big problems. It doesn't apply with any standards, and when used with Class 1 equipment, it could actually obstruct the earth path and mean that the Class 1 protective measure, the protective earthing, doesn't actually work on that equipment. So again, these can be very dangerous. Now, these aren't fake plugs. This is important to understand. They're not fake plugs. They're not counterfeit. They're not trying to be anything else. They're just what we refer to as substandard. So they're just simply dangerous plugs that don't conform to BS 1363. And they should be replaced by a competent person. Now, again, I would always say, if you see plugs like that and you think, all right, I'm going to rewire it, I'm going to put another plug on, just be careful, because if the plug's that bad, is the cable actually counterfeit? Is the cable substandard? Most times when you actually cut these things off, you'll see that the cable is very thin. It's not pure copper. It's the wrong colours. It's the wrong cross-sectional area. So again, sometimes it's not quite as easy as just changing the plug. And also then, what does it say about the equipment? Because if the person who's manufactured the equipment has put that plug on it, potentially then the equipment itself could be substandard as well. So you've got a lot of questions to ask if you do identify things like that, if the plug's substandard, it doesn't necessarily mean that just replacing the plug suddenly makes everything else comply. So always it should be setting alarm bells off when you look at that. All UK plugs must have a fuse. For non-rewirable plugs, this will almost always be located in the plug face, on the face of the plug. The examples used in the pictures above obviously had no fuse. Now, obviously, when we're saying all UK plugs must have that, we're saying all UK plugs to BS 1363. Obviously, your industrial type plugs are unfused, and that's obviously fine. The lack of fuses in the plug shown the previous slide makes them potentially very dangerous indeed. Fuses are present to protect the flexible cable between the plug and the appliance. If too large a current flows through the cable, it may overheat and ultimately catch fire. So again, the fuse is there for safety reasons. The fact that these have left that out shows obviously that there is a safety risk in that regard. So we always need to make sure that on any equipment that the plug and the cable itself and the fusing is correct. Plugs such as those shown are unsafe in other respects, not just because they're missing fuse. They're unlikely to have been tested for safety because they would have failed. They usually have unsuitable cable connected, incapable of handling the current that your appliance may use. I mentioned that before. 2 of the plugs have a plastic sleeve on the earth pin, which could prevent proper connection to earth. And the dimensions are incorrect, which could cause damage to the socket outlets or harm to yourself. Simple tools can make a lot of difference. So a low-cost solution which makes it easier for personnel to confidently make quick decisions can have a big impact. So again, this is an example of the electrical safety first plug check card. And if you haven't seen these or you haven't got one of these, I'd sort of recommend these, that you get hold of one of these. They're a useful device. Effectively, they're laid out in line with the British standard, so in line with BS 1363. So the spacing of the pins, the size of the pins, the red zone actually denotes the area where the shock risk is. So that's the area that you shouldn't be able to touch. So you can simply use this, as you can see on the right hand side there, to plug it in, and you can see, are the pins correctly spaced? Are they the right size? Can I see any of the red area, the safe area that I shouldn't be able to see? And also on the left hand side, you'll notice that there's diagrams on there, and you can use those as a bit of a gauge, put those up against the size of your earth pin and of your live pins, and actually see whether it actually meets the correct size for the insulation and the size of the metal areas on the pin as well. Now, it's important to say, these aren't calibrated. This is something that's printed out. So this is just an initial guide. If it fails this, then potentially you need to have a chat with the manufacturer of the equipment, or maybe dig into the standards a bit deeper, do some actual more accurate measurements. But these are a very good quick guide, and you might not need to do this. Somebody who's an experienced, competent tester might not need to do this on every item, but you might see an item and think, that looks a bit dodgy to me. Let's try it on the plug checker card, and go through and do that. So we heartily recommend these. These cards are available from Electrical Safety First. So if you go onto the Electrical Safety First website, you can have a look at these and you can buy them, and they're quite inexpensive. But we'd recommend these for anybody actually doing inspection of equipment in the workplace. Part 6: Equipment Racks and Bays. So this is a new appendix, Appendix 7, which has been included in the 5th edition. And for years, rack-mounted equipment has just been treated as normal pat testing equipment, but obviously there are some differences. Many items of equipment that could individually be considered mobile are often used in a fixed location, installed into equipment racks or bays. These individual items are typically only removed for repair or replacement, and the need for maintenance should be considered. A duty holder may decide to treat such equipment racks as installed plant, and on that basis the equipment should be subjected to an ongoing maintenance regime, typical of an electrical installation, which will comprise inspection and testing according to the nature of the installation and its use. In order to assess the degree of risk, the following factors should be considered: whether the rack is installed in a controlled area with access restricted to competent people, the existence of any maintenance program, whether the equipment in the racks is used by non-technical staff, how often equipment is replaced, for example for upgrades, change of use or repairs. What other electrical measures are in place, such as RCDs or residual current monitoring, the current state of repair of the existing equipment, and the nature of the environment in which the rack is installed. Duty holders should ensure that equipment under their control is inspected and tested by someone suitably competent, as additional risks may be present, such as multiple power supplies, auto-starting backup supplies, or critical operational equipment. So there is quite a bit in here, and obviously today we're just giving you a flavour of what's in there and really just letting you know that there is now an appendix to cover this type of equipment, and the Code of Practice does recognise now that it needs to be treated a little bit differently because of the level of risk there, and also the type of equipment and the criticality of some of this equipment as well. So again, this is probably something we're going to visit at a later date in more detail later in our sort of range of 5th edition webinars, but for now I would just have a good look at that and just really get to grips a little bit with those requirements. And obviously if you are testing installations that do have equipment racks and bays, or you are a duty holder for such installations, then obviously it'd be worth having a good dig into that and really get your teeth into the new requirements that have been included in the 5th edition for that. Part 7: User inspections and competency. So there are three types of in-service inspection and testing detailed in the IT Code of Practice. User checks, formal visual inspections, combined inspection and test. A well-designed PAT testing policy will utilise all three. Now, we're quite familiar with these. This is nothing new for the 5th edition. This was always in previous editions. However, there is a new emphasis now in the 5th edition on user checks, on the importance of user checks. The new Code of Practice promotes greater application of user checks. The intervals between formal inspection and testing can take into account users of equipment being more proactive about checking the equipment and reporting faults. So when we're doing a risk assessment, or where the duty holder is doing a risk assessment, if the user is being proactive and doing very proactive and regular user checks, that can be factored in. And that's a factor they can include, and actually something that they really should include in there as another control measure to manage the electrical safety of equipment in the workplace. Most electrical hazards in the workplace, for example, from damaged flexible cable or broken connectors, can be seen with the naked eye and do not require specialist electrical training or test instruments to identify. So, you've got a plug with a broken off pin. Again, pretty much everybody would be able to identify that, whether they had a high degree of training or not. Obviously, we would recommend users do have training on how to carry out user checks, but again, it just points out that actually just getting people to get into this regime of doing these user checks can actually identify these things with minimal effort, really, from that side of things. In the 5th edition, they've also included a new poster now in there to promote user checks and promote electrical safety within the workplace. So again, they'll be available from the IET. So user checks. User checks are simple visual inspections carried out by the user of equipment or another designated person, e.g. a school teacher or a member of staff. These would be done either before use or at a set daily or weekly intervals. The visual inspection is supplemented by basic assessments by the user as to the equipment's suitability for the selected environment and the nature of the task that's been carried out. So they wouldn't just look at the equipment, they're looking at the equipment and saying, right, is it suitable for the job I want to do with it? Is it suitable for where I want to use it? Users must be trained how to perform a user check and must be made aware of their responsibility to perform user checks at the intervals prescribed in the risk assessment. Now, competency. This is an important thing in here, and this is sort of something that's been around for a while. It's come from the Health and Safety Executive Guidance, HSG 107. And what they actually recognise in there, the Health and Safety Executive, is they've actually recognised 2 levels of competent person. So they've pretty much defined 2 levels of competent person now for carrying out portable appliance testing. And this is nothing new. As I say, it's been in HSG 107 for a while, but it's now been included into the 5th edition. So it's brought it to our attention, really, from that side of things. So they define a level 1 person as a person not skilled in electrical work who routinely uses a simple pass-fail type test instrument where no interpretation of the readings is necessary. The person would need to know how to use the instrument correctly, providing the appropriate test procedures are rigorously followed and acceptance criteria clearly defined. This routine can be straightforward. So what they're actually including in here is the provision for actually a person who is still competent, but is not effectively electrically skilled, is not electrically trained person with a lesser degree of training. But because they're using a very simple go, no-go type test, or something like a Seaward Prime Test 50, and presumably they're testing within quite tight boundaries, so they're testing a limited range of equipment that they're very familiar with and they've been trained on. So you can imagine somebody like a cleaner who's testing his vacuum cleaner, every 6 months or something like that, with a very simple tester. That person could be considered a level 1 competency, a level 1 competent person to actually carry out that testing. So that's an important definition. Historically, people have always looked at, sort of competency as competency, whereas the HSE are actually defining here now level 1 competency. Level 2 competency is a person with appropriate electrical skills who uses a more sophisticated instrument that gives readings requiring interpretation. Such a person would need to be competent through technical knowledge or experience related to this type of work. So again, the normal type level that we'd expect from a normal person doing portable appliance testing would be, a level 2 person from that side of things. So it's just an interesting, definition that the HSE have actually put into their guide, HSG 107, and this has now been included in the 5th edition. So just be aware of those terms, level 1 and level 2 competency, that's been added in now in the new code of practice, so you can have a look at that. Enhanced user inspections. So this is again what we would probably call somebody who's operating under level 1 competency. Sorry, he's just using a simple no-go tester. There is an option to say, actually, could we carry out what we call enhanced user inspections? So could we do a user inspection, a user check, a visual inspection, but actually add a very basic test with a go, no-go style tester, a pass-fail style tester, to actually check the things that they can't physically see. So there are many ways in which companies can enhance their user inspection process, one of which could be the use of a portable appliance checker. And obviously training should be provided on the use of the equipment. Using a simple pass-fail type pat tester like our Prime Test 50, when carrying out a user check, will identify potential hazards and faults sooner. So what we're actually doing is we're doing a user check, but we're actually giving that user the ability to actually check things like the insulation resistance and the earth continuity as well. So the things that historically might have only been picked up maybe every 2 years when the person comes around to do a formal pat test, could now be picked up as part of an enhanced user check. So it's something that's, we think is quite an important change, and it's something that duty holders could actually factor into their processes. So these can be considered in the risk assessment process when defining frequency of formal visual inspections and combined inspection and test. Visual inspections and enhanced pat checks can be carried out on new equipment entering the workplace without the need for a full inspection and test, also potentially picking up on possible counterfeit products. So yeah, we think as well you could use this, somebody who's a level 1 person could actually use a basic pat checker to actually screen equipment coming into the workplace. So we're still saying it would still get a formal portable appliance test in the testing interval defined by the duty holder. But actually often this equipment might just get a visual check, enter the workplace, and actually we're not sure, there could be a defect there could be a problem, where it's counterfeit or something like that. And that would actually be picked up by just using a simple go, no-go pat checker, really, from that side of things. So again, something to think about for duty holders really is enhanced user inspections. Obviously, the code of practice is promoting user inspections. We've now got the definitions in there for level 1 competent persons. So the two coming together there really give us this option to say, well, what about enhanced user checks? In which case that actually gives us a better level of screening at the start. It's not a replacement for traditional pat testing, it's an enhancement, it's an addition to that to actually improve the level of checks carried out by users. Part 8, rented accommodation and landlord's responsibilities. More details now have been added to the new code of practice with reference to rented accommodation and landlord's responsibilities. Section 316 of the code of practice covers the Housing Act 2004, England and Wales. This came into force in April 2006, and an important change was made which introduced a new method of risk assessment called the Housing Health and Safety Rating System. The rating system was designed to assess all hazards that may be present in a residential property, and from an electrical perspective, that includes the electrical installation and equipment provided in the property, including associated leads and plugs. Following the electrical maintenance requirements of the Code of Practice is a method of demonstrating that equipment is safe for continued use. Guidance from the Ministry of Housing, Communities and Local Government indicates that when accommodation is re-let, the electrical equipment will be classed as being supplied to that tenant for the first time, and should therefore be rechecked. Section 317 covers the Housing Act Scotland. The Housing Act Scotland 2006 as amended applies to landlords and tenants in private sector housing, although some provisions within the Act do relate to housing rented by local authorities. Chapter 4 of the Act, the Repairing Standard, defines the statutory requirements that have to be met by a private landlord. From an electrical perspective, these cover the electrical installation, electrical equipment, electrical heating, lighting and hot water systems. Landlords must ensure the property meets the repairing standard at A, the start of the tenancy, and B, times during the tenancy. Following the electrical maintenance requirements of the Code of Practice is a method of ensuring that equipment is safe for continued use. 318. The Housing Wales Act 2014. This was brought in as a compulsory registration and licensing scheme for private rented sector landlords and letting and management agents, and also introduced requirements for local authority housing. Section 40 of the Act requires ministers to issue a code of practice setting standards relating to letting and managing rental properties. Section 22 of the Act makes it a condition that any person issued with a licence under Part 1 of the same Act must comply with the Code of Practice. The Code of Practice makes it a requirement that supplied electrical equipment must be in a safe condition. Section 321, Landlords. Landlords have a responsibility as outlined previously in sections 316, 317 and 318. Equipment is rented accommodation must be safe and kept in a safe condition. If supplied as part of a tenancy, equipment should be checked for safety periodically as required. Each time a new tenancy is arranged, the equipment should be rechecked. This requirement applies to housing as well as holiday lets and other short-term rental property. Part 9. Other things to note. Section 442 covers USB sockets and power over Ethernet. The inspection and testing of USB and power over Ethernet circuits and peripheral equipment such as computer mice or CCTV cameras, for example, is outside of the scope of the Code of Practice. So the actual inspection and testing of these devices is not covered within the scope of the new Code of Practice. Although the voltages are low and generally may not present a risk of shock, both can develop significant energy, which may pose a fire risk if not maintained. So even though the actual inspection testing is not within the scope of the regulations, duty holders may decide to include such equipment in a maintenance regime, and they may still risk assess that equipment to see how it's going to be dealt with. And also something to note, that power supplies used to derive USB and power over Ethernet voltages, such as mobile phone chargers and network switches, are generally within the scope unless they're part of the fixed installation. So although the actual equipment themselves, like a mouse, a USB mouse, wouldn't be within the scope, the actual charger or the computer or whatever that actually provided that that energy, which actually supplied that equipment, could well be within the scope of the Code of Practice. So again, it's important even that things like USB sockets and power over Ethernet equipment are actually checked and are risk assessed really by the duty holder to see how they want to deal with these things. Another thing that's worth mentioning, which I think is a good inclusion in the book, Appendix 8 is actually electrical units and calculations relating to inspection and testing of electrical equipment. So a new appendix has been added to provide a good working knowledge of the standard units of measurement that might be encountered during equipment testing. It's essential not only to know the units and the quantities to which they relate, but also to have a good understanding of how their properties are affected. For example, changing cable length or cross-sectional area. So this is a great appendix actually for new engineers, people doing training courses. It was always something missing when you did the City and Guilds course. There'd be questions about Ohm's law and things like that, and it'd never be actually covered in the code of practice. But also people like duty holders who might not be, 100% up on the electrical theory, but have been given, reports and forms, and they've got to actually interpret test results, things like that. So again, having this in the book and having that in there to just give you a brief overview of sort of, basic electrical theory, shall we say, I think Appendix 8 is a good addition in there and well worth a read for anybody who's sort of wanting to refresh their skills or just new to the subject, really, from that side of things. Part 10, 5th edition products. So to finish off this webinar, I want to just talk to you about some of the changes we've made to our products in relation to the 5th edition. Now, this is very much just a taster to give you a quick overview of what we've done, and we will be bringing out more specific content later on. So I just want to give you a quick overview. So first, let's have a look at what we've done at the Prime Test range of products for the 5th edition. So to start with, for the Prime Test 50 and the Prime Test 100, we've actually added in the ability to test at 250 volts. So previously you could only test at 500 volts, which meant if you wanted to test surge protected equipment or very sensitive equipment, for example, you were stuck really because you didn't have an option to do that. Obviously most equipment would be fine at 500 volts, but giving you the option to test at 250 volts is a nice additional feature. So the way we've done it with the Prime Test 50 is the Prime Test 50 will actually default to 250 volts. So 250 volts is the default setting. So less skilled users, and we talked earlier in the webinar about the sort of level 1 users, level 1 competency, will be able to carry out tests knowing that they're not going to damage any equipment and they're not going to have to change the settings or anything like that. So it defaults to 250 volts. And if you want to actually test at 500 volts, you hold the test button down longer and it actually then changes over for that particular test to 500 volts. It'll carry out the 500 volt test and then give you obviously the pass or fail. So on the Prime Test 50, that's just a simple user interface. It's just defaults to 250, but if you hold the button down longer when you do the test, it'll change over to 500. Whereas with the Prime Test 100, we've actually added in a settings menu now. So there's a settings menu and you can actually go in and set the default test voltage, whether you want it on 500 or 250 volts. So nothing really to do with the 5th edition, that it's just the update. So as we're doing this update, we've made a few improvements. So that's something we've added in. Obviously, I mentioned earlier about the 5 milliamp leakage test limits. The 5 milliamp leakage test limits are a 5th edition thing. It's been changed, and we've had to do changes to the firmware and the hardware within the products to actually allow it to measure the full 5 milliamps range. So a lot of PAT testers out there, and and a lot of other makes of PAT testers out there might not have made this change. So it is something where, from Seaward point of view, we're saying, to be fully 5th edition compliant, we've included this in. If you've got an older tester, obviously you can still carry on using it. It'll just work to a lower pass-fail limit, whereas these will actually measure all the way up to 5 milliamps. So actually we've had to do changes to that, particularly for the touch current, to make it actually measure all the way up to 5 milliamps. So we've made those changes to the Prime Test 100 and the Prime Test 250 Plus. There's no leakage test option on the 50, so that's why we didn't include it on that. User selectable earth continuity limits. Again, on the 250 and 250 Plus and the Prime Test 100, we've actually allowed the user to be able to select from 3 options for the default earth continuity limit. So you can now choose between 0.1 ohms, 0.2 ohms and 0.3 ohms. So historically we've always had a pass-fail limit of 0.2 ohms, which was obviously higher than the 0.1 plus R specified in the book, and you couldn't change it because it was just preset in the tester. We just picked a good middle of the road value that worked for most people, and that's what we did. Whereas now you've got the ability to select, do you want it as 0.1, 0.2, 0.3, and you can choose that via the settings menu for both the Prime Test 100 and on the 250 Plus. Long lead option. So historically, again, having a set pass-fail limit was always difficult because if you've got long lead, then potentially you test in a long extension lead and it fails because it's over the preset limit. So now we've added in a function in here where it'll actually come up and say to you long lead, So it'll ask you, is it a long lead? And then you can actually carry on and do the test, and it will test that and give you a value for those. So again, that's been added to the Prime Test 100 and the 250 Plus. We mentioned Class 2 FE, Class 2 Functional Earth. We've actually added that functionality onto the Class 2 test, again for the Prime Test 100 and the Prime Test 250 Plus. So if you are testing Class 2 FE equipment, when you do a Class 2 test, if it detects an earth path, so if it detects an earth connection, it will actually ask you, is it Class 2 FE? And if it is, you can actually carry on and do that continuity test as well as the Class 2 insulation resistance test and the leakage test, and that will actually give you the values for doing that. So you can actually carry out testing of Class 2 FE equipment. Again, that's another 5th edition requirement. And something else we've added in, not really from a 5th edition point of view, but because it's something we're asked about more and more and more, is Class 1 with no exposed conductive parts. So a lot of times you'll come across equipment like office fans, for example, where they have no exposed earth parts. It's all plastic on the outside. It's Class 1. There's an earth connected to the inside, but all the stuff on the outside is insulated. There's nothing there for you to actually test to. So you've got two options really: either physically take it all apart, or you poke screwdrivers in, or all those sort of things, which is generally seen as bad practice. Or what we would advise our Apollo users to do is to have a test sequence there where you omit the earth continuity test and you record down, you say no, it had no exposed parts. So you'd actually record that down and in the comments, and then basically that would be a test. It would be the same test you do a Class 1 earth continuity test, but you'd omit the continuity test, but you would do the insulation resistance test. So again, we've added that in to give people the ability to do those. So that's really a very quick overview. There's probably a few more things in there that I haven't gone into detail on, but generally that's the sort of refresh of the Prime Test range. You'll notice that we've actually updated the Seaward logo and the branding on the products as well at this point, and also put a little 5th edition marking on there to actually say that these are the 5th edition versions of these products. Now with the Apollo, what we've done with the Apollo series, again, very similar really from that side of things. Not huge changes to the Apollo, but we've written a whole new suite of test sequences. So that's the main change. We've actually included every test sequence, default test sequence in there. We've done from scratch. We've been able to include things in there like Class 1 with no exposed metal parts, Class 2 FE, and things like that in there. Obviously, the main change as well is we've updated the hardware. So we've done a hardware modification to allow the measurement range of the Apollo to measure all the way up to 5 milliamps for the touch leakage. That has to be a hardware change. You know, it won't measure. It was previously only had to measure up to 0.25. The measurement range on the tester was actually up to 3.5. We've had to extend that through hardware changes and obviously firmware changes. And also all of the new test sequences will have the test limit changed for the 5 milliamps. So effectively with the Apollos, that's the main change. We've changed the test sequences. There will be a new firmware coming out, which will be available for existing users to download free of charge. Obviously, the new products will include the firmware anyway, and they will include the hardware changes too. Users who've got an existing Apollo won't have the hardware changes, obviously. So what happens when you put the new firmware on? Well, when you put the new firmware onto existing Apollos, it will just extend the measurement range, but only to 3.5 milliamps for touch current. For protective earth current, protective conductor current, it will actually measure up to 5 milliamps. The circuitry would allow for that. So with the firmware change, you'll be able to do the full 5 milliamp tests for protective conductor current. So that'd be the sort of test you'd normally do on Class 1 equipment. But it's the touch current that actually needs extending. So the only difference really, if you're an existing Apollo user and you put on the 5th edition firmware, the only difference is your test sequences will only allow you to measure up to 3.5 milliamps for touch current, whereas obviously now the code of practice says it's 5 milliamps. But considering previously everything was only 2.25 milliamps, quarter of a milliamp, I don't think you're going to come across much equipment that's actually got touch currents, you know, greater than 3.5 or that sort of thing. So again, working to the older limits, all we're doing is the older limits are tighter limits. whereas now, obviously, the limits have gone up to 5 milliamps. So really, from that side of things, there's no real safety concerns from that. It's just the fact that the new limits are actually 5 milliamps. So at Seaward, we wanted to make sure our products comply fully with the new code of practice. So we've added on that. So again, when the firmware comes out, we're looking for the firmware to be released probably the end of September. To coincide with the products. Products should be available in sort of start of October, really. So then you'll get the new products and obviously the new firmware there to download, and you can obviously install that, get the new test sequences and all that good stuff really for existing Apollo users really for free. So that's something to look forward to. So that's just a quick overview of the product changes. Obviously, when the products are fully launched and they're out, to say that'll be sort of start of October. We'll obviously do more content relating specifically to the products, and we'll show you that in more detail. But that just gives you an idea of what's coming and what changes we've made. So this brings the webinar really towards a close, and we put on our promotional materials that everybody attending the webinars would have the opportunity to win a new 5th edition Seaward Prime Test 100. And what we will do is after the events, and obviously once the products are available, we say that that'll be from the start of October. We'll draw out by the attendance list the people who attended each event. We'll do a prize draw. We'll draw out one lucky winner, and that person will get a Seaward Prime Test 100. As I say, they won't be available for shipment until sort of the start of October. So just for those of you who are on the earlier events, just bear with us on that. If you're in the events in October, then obviously that's fine. It'll be out with you straight away. So one of you lucky people who's kindly watching this webinar will win a Seaward Prime Test 100. So we haven't forgotten about that. We'll do the draw once the event's gone through, and then obviously we'll notify you of that and let you know who the lucky winner was. So fingers crossed, hopefully it's you, and hopefully you win one of these fantastic new 5th edition products. So finally now, it's time for your questions. So really this is the bit. We've obviously been having your questions. You've been posting away on the chat box and we've been answering as we've gone through. But anything that we haven't covered, anything you've got more detail on now, feel free, now's the time, please type into the chat box and we'll start that. So I'm going to go over, we're going to turn the mic on, and we'll answer your questions live in person. So let's wait for that.